Class 12th, Chapter Semiconductor Electronics. Electronics, no doubt, has made our lives quite easier as compared to the earlier times. Electronic devices are everywhere around us. Whether you talk about a laptop, mobile phone, charger, television, or a remote control. We cannot imagine our life without electronics now. So, this chapter will introduce you to the basic components of any electronic circuit like diode, transistor, etc., and the material that is used to make these components, which is a semiconductor. The conductivity of semiconductors lies between conductors and insulators. There is another way of classifying solids as conductors, semiconductors, and insulators, that is on the basis of energy bands. अब ये energy bands क्या होते हैं? In simple language, you can call it as band of energies or set of closely spaced energy levels. Let's try to understand how these energy bands are formed in case of a semiconductor. Take the example of silicon. Its atomic number is 14 and electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p2. So in total, we can say that it has got 4 valence electrons. See, if we consider a single atom, then these energy levels are discrete. But what about a crystal? In crystal, the atoms are closely packed. So, the energy levels cannot remain the same as in case of individual atoms. Consider a silicon crystal consisting of n atoms. Now, when the interatomic spacing is very large, each atom behaves independently. तो एक एटम में अगर outermost subshell 3s में 2 states थी और 2 इलेक्ट्रॉन्स थे, तो n एटम के केस में 2n states और 2n electrons हो जाएंगे. Same goes for 3p. For a single atom, there were 6 states, out of which 2 were filled by 2 electrons. But now you have n atoms, so we have 6n states, out of which 2n states are filled by 2n electrons. Now, as you start decreasing the interatomic spacing, what happens? The 3s and 3p levels splits into large number of closely spaced energy levels where the electrons can have either energy slightly less or slightly more than the original energy level, as you can see in the region B to C. Now, if you further decrease the interatomic spacing, the energy gap between 3s and 3p disappears. That means now in total you will have 8n states, 2n corresponding to 3s energy level and 6n corresponding to 3p energy level. And these energy states are continuously distributed. Now, can I say that out of these an states, 4n states are filled और ये 4n में 2n आपकी 3s से आ रही है और 2n आपकी 3p से आ रही है. So, 4n levels are completely filled with valence electrons and other 4n levels are empty. If you further decrease the distance between the atoms, you will reach the state of equilibrium, and what you will see that under equilibrium separation, the filled and unfilled energy levels will be separated again by an energy gap which we call as forbidden gap, which you can see at point A. Now, the lower filled states form a band which is known as valence band, and the upper unfilled energy band will be called as conduction band. So, in total, that is from 8 you will have 4n filled states and 4n unfilled states. So, the separation between the valence band and conduction band we call as the forbidden gap. Now, this is the case of a semiconductor. Now, what happens in case of metals? That is your conductor and insulator. Let us try to see in the diagram. So, as you have seen earlier, in case of semiconductor, there is a band gap between the conduction and valence band, okay, and that energy gap lies between zero point 0.1 to 3 electron volt. But in case of metal, the valence band and conduction band, they are partially filled and they overlap with each other. Now, in case of insulators, the valence band is completely filled with electrons and the conduction band is empty. But both the bands are separated by a forbidden energy gap of about greater than 3 electron volt. So, it is very difficult for the electrons to go from valence band to conduction band. It is almost impossible. But in case of semiconductor, if you give them a little bit of energy, then the electrons can move from valence band to conduction band. That we'll see in the next video. Thank you.